Hello. Is this screen is visible?
Yes, sir.
Okay, thank you.
Sir, you told that seminar we will be taking, sir.
Are you ready now?
Sir, but only alone, sir. I will ask my friends to join, sir. 1 second, sir.
Yeah, whenever they are ready, you can tell me. I'll stop the teaching and you can present your seminar. Okay.
Okay, sir. Shall we start now only, sir?
Okay. Let's start.
Oh, 1 second, sir.
Mhm. Okay. Until that, I will start my lecture. So when all four members and your presentation is ready, you can inform me. Okay.
Okay, sir. Okay, sir.
Not waste the class timings.
Okay, sir. Sorry, sir.
Yes. Now coming to the other part of the module 4, okay, of the unit 4, that is the solar photovoltaic systems. Just a minute. I'll make it full page. Yes. Now the audio and video is clear.
Yes, sir.
Okay. Now coming to the solar photovoltaic systems, all of you know the principle of photovoltaic concept. That is, whenever the light falls on a semiconductor material or the material which is having more electrons or the photons or the sorry holes combination, then we can have or we can see the small EMF can be generated between the junctions, or whenever a PN junction is possible, positive and negative junctions, and light falls on that surfaces, we can have some small electrical motive force is generated so that we can observe. So that concept is called as photovoltaic effect. So here these photoelectric cells. Now coming to the concept of these PV systems. So earlier until now we have discussed about solar heating systems, liquid flat plate collector or by solar air heaters using plates and solar concentrating collectors, various types and designs we have seen. In this part, we are going to discuss only the electrical energy generation. Okay. So coming to this different part of solar energy conversion. So here we are going to convert the light energy into electrical energy. And whenever these type of PN junctions are exposed to light, so their characteristics which are containing electrons and holes, because of that pair formation and the overcoming the band gap between these electrons and holes, one can see there is a change in current, voltage, or the resistance. Or also we can control the voltage, current, and resistance by changing this sunlight itself. So in the sunlight we have some energy. So that we need to convert in the form of electrical energy other than heat energy. So coming to one simple solar cell. So this solar cell, if you see the left side sketch cell. So this is a very minute and basic component in the solar array or the modules. And this cell is prepared using N and P type materials. And after making a PN junction component, so we are going to have these connections. So these vertical lines you can see, these are the connectors where you can connect the solar cell in parallel and series. Okay. So once you connect all these cells in a given area, so that will form a module or a solar panel. So whenever we see the solar panels or the modules, it is containing many number of cells. So this cell will generate some small EMF, and if you combine in series or parallel, we can generate more voltage and current. Okay. So these panels in applications, if you see, these will be connected in such manner. Okay. So if they are connected side by side, so these are the parallel connection. And if you connect in line, say for example these vertical lines in line, if you go on connecting one above each other, so that becomes a series connection. And side by side we can connect it so to make it parallel or series. So once you make it this type of arrangements, we are going to call it as string or array of solar panels to generate the required maximum current and the voltage for the applications. Okay, if the for the application, if the current and voltage is very less, then we can go for only single module and we can use that energy only for the lighting purpose. If you want to run for a big machines or very high voltage applications are required, then you can go for n number of modules. Okay, as per the requirement, because the company will be giving the rating for one module, how much energy can be generated. According to that, you can purchase n number of modules and you can arrange it in array, like in series or parallel. Then you can use it for the various applications. Okay, so which are the materials used to prepare this solar cell or a solar module? If you see, which converts the light into electrical energy, we have various types of materials in third, fourth, and fifth periodic table. These columns, if you see, we have many number of materials. So majority of the materials used to prepare the solar cells are nothing but these materials. Fourth column, what you can see in the periodic table. In this column, whatever the materials are there, carbon, silicon, germanium, okay, or lead or SN, whatever it is. So these materials can be used for preparing the solar cells. And in this, silicon is available in the majority of the cases and it's very low cost. Okay. So many examples, if you take the solar cells or the solar modules, silicon is maximum times it is used. So here also, if you see the materials, it is again combination of the different materials. So that what we are doing here is silicon can be doped or mixed with this third or fifth column materials so that it can make a N type or P type material or negative or positive type of materials. So that we have different combinations like silicon, then we have germanium arsenide, cadmium telluride, or copper indium selenide. So coming to the material preparation, as I told you, the doping is made for the semiconductors. So without doping, if you call these materials as a silicon, as a single material or germanium, so those are the intrinsic materials. So intrinsic semiconductor means without any doping or without any mixing. But once you go for the doping, which is the process of adding impurities or the different materials in the given base material, once you add these impurities, what will happen? These intrinsic semiconductors can be converted into extrinsic semiconductors. Okay, so because of that, what will happen? We are altering the number of holes and number of electrons in the given N and P type materials. So this doping creates N type material when a semiconductor material or the intrinsic material in the fourth column, if you add with the group 4, here group 4 material, what I told, carbon, silicon. If you take one example like silicon or germanium, if you dope with group 5 atoms, okay, group 5 atoms are what? N, P, As, Sb, Bi, like this. Okay, various materials are there, like arsenide. Then we have phosphorus, like that. Examples are there. So those pentavalent impurities or the materials, if you add with the group 4 materials, which are the base metals, then it will become a extrinsic semiconductor with more number of electrons because it is preparing N type of material. In the same case, if you dope the material in group 4, like silicon or germanium, with group 4 or no, sorry, group 3, that is trivalent impurities. Say, for example, boron, aluminum, then gallium, indium, like this. If you go on adding these trivalent material with this group 4 periodic table materials with silicon or germanium, then it is going to prepare a positive or P type material with more number of holes. So by preparing this more number of electrons and hole materials, what we are going to do is we are going to improve the semiconductor properties where we can make excess electrons in the N type material by making it more negative or by making more doping process. Or if you go for the P type material generation, we can generate more number of holes. Okay, so like this, we are going to change number of electrons holes in the given semiconductor materials. So before doping, as I told, it is called as intrinsic semiconductor. After doping with different materials, it is called as intrinsic semiconductor. Sorry, extrinsic semiconductor. So in the N type, the minority carriers will be holes because N number or the negative charge carriers of like electrons will be majority cases. In the P type, if you see, holes are more after the doping. So because of this, what will happen? Electrons will be very less. And because of this combination of more electrons and holes at the PN junction, we can generate a small EMF when it is exposed to the sunlight. So now coming to the working. So in the working, you can see the small solar cell is taken here as an example. See the N-type material, the thickness you can see only up to in a general solar cell. Okay, so in the thickness of the N-type, if you see 0.2 micrometers, this itself can enough to generate maximum electrons, which can pass through the circuit here. At the backside, the circuit is shown, where the electricity of the EMF generated can flow through the load, and it can come back to the positive part of the solar cell. And the P material or the base material, if you see, the thickness is 300 micrometers. So we need very big dimensions for the P junction and very low dimensions for the N junction because electrons can be generated very easily compared to the holes. The holes will be just supporting us so that we can collect the electrons back to the circuit so that the circuit can be complete. So whenever the electrons flow from one region to other region, there should be some gap so that electrons can come and fill there. So we are calling that hollow region or the vacuum region as a holes. So at the top you can see for making the connections and connecting the circuits, we have some fingers or the fringes or the grid-like connection. So these connections are required to connect a circuit or the load or between number of cells to make a module. So these connections are required at the top. So always the N-type material should be focusing or the facing towards the sun, and light whatever it is falling, this will generate or it will pass through the band gap, should overcome the band gap, and that band gap should be less than the whatever the wavelength of the sunlight is passing, it should be less than that. If the band gap itself is more than the required energy what is passing on the N-type region, then it will not create any electrons or it will not complete the circuit, or there will be no electrons flow in the circuit. Okay, that band gap is very important. Now to check the amount of electrons or the EMF generated, we can use this equation. That is E equal to hc by lambda. So here c is nothing but velocity of light, all of you know. Then h is the Planck's constant. So that is 6.62 into 10 raised to minus 27 hertz. So this is given here. And after substituting, one can tell that whatever the EMF or the electron volt is generated for the given PN junction, so it will be found out by using this wavelength of the light, okay, lambda, wavelength of the light which is falling on the N-type material, and this multiplication of H and C, that will be constant, 1.24. So any given light wavelength, what is the energy generated? That will be 1.24 divided by wavelength in micrometers. So if this equation is known, one can find out what is the energy generated for a given light. Later, it all depends on the efficiency of the solar cell. So how much energy out of total energy, how much it is going to convert. So this is about the working of a solar cell. Next, coming to the properties of N-type and P-type, as already I told you, extrinsic. So N-type is an extrinsic semiconductor after doping, which is obtained by doping the impurity of pentavalent. So if you dope with a pentavalent material, it will become N-type. If you dope with trivalent or the third group of periodic table materials, it will become P-type. So example for N-type doping materials like antimony is there, phosphorus is there, arsenic is there, okay, with the pure germanium or silicon. So as these materials are available large in scale, so germanium and silicon is preferred. Similarly, in the P-type, if you see, we can add in the trivalent impurities such as boron, gallium, indium, etc., so that we can generate or you can manufacture P-type semiconductor. So both the materials are required to prepare a PN junction. So these impurity atoms added will provide extra electrons in the structure called as donor atoms. So electrons are the donors. And these here in the p type, if you see, whatever the number of holes extra we have generated, those are called as acceptors. Okay, so donors and acceptors, these also will have some energy. So once you prepare this more energy between the donors and acceptors, more electron flow will be there. Also, the band gap between the p and n junction, or the conduction and valence band, if you see, if that is reduced, more electrons or the resistance will be less. So like that, we are going to prepare the p-n junctions. Also, the electrons are the majority charge carriers, as I told, than the holes in the n-type material. In the p-type material, it is just opposite. Holes are more and electrons are less. Now coming to the working process in this, as I am telling again and again, the energy gap. You can see here, there will be, if you take any electron hole pair, there will be always the energy gap between the orbits, between the valence band and the conduction band. So the light, whatever is falling on the given cell, so as you can see, the for notation they have given solar radiation which is falling on the surface or between the p-n junction. So once it falls, this radiation or the energy of this solar radiation, this should be more than this energy gap between the holes and electron pair. Then only what will happen? This electron, it will energize, okay, by the solar radiation. Then it can pass through this energy gap and it will reach the hole or the valence band. Then electron flow is possible in the given junction. Is that clear? So p-n junction, between this we need to just find out what is the energy gap value. If that energy gap value is less than the solar radiations, then that type of material can be used for converting light into electricity. So next, coming to the PV system advantage, disadvantage. Already many students are knowing about the photovoltaic systems in one or the other subjects, or outside you can see nowadays many buildings or many applications you might have seen the PV systems. The first and important advantage is this is the free of cost energy. Solar energy is continuously available at free of cost. Only in some conditions, like climatic conditions, we are getting intermittent solar radiations, which are unpredictable in nature. That is a problem. Also, the diffuse radiations we cannot control. And in the night time or after the sunset and before sunrise, we don't have solar radiations. So in such conditions, we have to go for the battery storage systems. So, okay, that's one of the disadvantages. And directly we cannot use this photovoltaic converted energy because it is a DC current. Direct current is generated, and to convert this and store this, all we need is inverters, batteries, or charge controllers, okay, or controlling the charges to the home or the grid. So all these extra equipments or the accessories are required in these PV systems. And other major advantage is it is very clean energy and the silent. You cannot hear the sound of converting this light energy into heat energy or the electrical energy. So that is one of the advantages. And the structures required to be prepared are very big. That is not an issue. But compared to the other energy sources like renewable energy source, if you see wind, tidal, or ocean, we need a big structures, and those are all operating with the maximum stress and strain. But here, these panels are just fixed on the roof, and continuously it will just absorb the heat or light, and it can convert it to some form of energy. And cost is currently on a fast reducing track. The cost here is it is for the manufacturing of PV cells. So that cost is reducing nowadays because of the more research and inventions with the low cost materials and other things. Also, the processing cost is also reducing. So now one can think of going for this energy, which is a sustainable in nature. Because all other energies like power generation from steam or coal, if you see, it is not a sustainable. Parallelly, it is polluting nature and also it is depleting the resources. But here we are not depleting any resources. It is a free energy available continuously. Every day we have sunlight, but sometimes because of the climatic change or the season change or the location changes, it may be a little difficult. Only that thing we have to overcome. Then operating and maintenance cost of the PV panels are considered to be below because only surface cleaning is required. Maintenance, if you see, everything is a standalone system without any moving parts and other things. If you have any sun tracking systems or some mechanical moving parts, then only it is a difficult job to maintain the PV systems. Okay. Now coming to the disadvantage, last 2 points, if you see, already these points I have explained. Last 2 points, if you see, this requires large area, so it will consume lot of area. So to overcome that, also we have one solution. You can go for concentrating PV systems, so that in very less area itself, you can concentrate more light and you can generate more electrical energy. Also, this efficiency levels, okay, these are the very low in applications. So as of now, it is around 14 to 25%. But if you go for concentrating type of solar energy systems, then efficiency can be improved. Okay. Any connection errors or problems here?
No, sir.
Okay. Am I going fast?
No, sir. It is okay, sir.
Okay. It's now coming to the voltage and current characteristics. This is very important for our calculations and numerical part is concerned. Here you can see how the solar panels can be connected so that we can change the current and voltage characteristics. The first important is connecting those modules of the solar cells in series. Okay, series means, as I told, these solar cells. These solar cells, the two lines of the cell, what you can see here, are connected one above the other or one below the other. That becomes a series connection. Okay, or else you can module only you can keep and connect in series. So if you connect in series, what will happen? The voltage can be improved. The voltage between the points can be higher if you connect in the series, or if you connect the modules in parallel, or you can see this sketch for easy understanding. Here, series connection of the solar cells. If you see here, with the module itself, in the module we are going to connect the solar cells in series. This will increase or decrease the voltage. And if you connect these solar cells or the modules in parallel, so taking these 2 points at the end and connecting parallelly with all the solar cells or with all the modules, if you connect parallelly, what I'm doing is I'm going to change the current. So similarly, in this graph, it is explained like as you go on connecting the solar cells in series, what will happen? I can improve the voltage because for the heavy devices or the very big machines, if you see, the voltage required for running the machines is very high. But compared to the other applications with the very low voltage applications, we need only current, maybe high current or low current, whatever, with low voltage. Okay. So like this, if you again connect the solar cells in series, parallel. So in parallel, what will happen? You can increase the current, not the voltage. So it all depends on the application. For given application, you have to decide how many number of solar cells or the modules can be connected in series and how many solar modules or cell can be connected in parallel, depending upon the required maximum power point or the power of the system. Now coming to the MPP, that is maximum power point. In the below graph, you can see for required maximum power point. Okay, so maximum power point, you can see this point or the tip of the curve. You can see for the required maximum point. So this point is the maximum power point required for the application, you can assume. So for that application, what I will do, I will take the number of cells, I will connect in series as well as in parallel, and for the required current and voltage, I will set up a system. I hope you are getting. So those number of cells in parallel and series in combination, after connecting, it is going to generate a maximum voltage point and the maximum current point. So in this curve, if I want to explain you, Imax is the maximum current what the parallel cells are generating. In the series connection, maximum voltage is generated at this point. Or you can say when the circuit is open, the voltage what you measure between the PN junction or the entire PV system, that is shown on the x-axis. That is the maximum voltage from the given system can be generated. And if you see here, short circuit, that is once you connect both the wires, okay, positive and negative, with the PV system, the maximum current what can pass once you short or once you connect, that is Imax, which is shown here. So once these two curves are available, or these 2 points are available, at the in between point, okay, optimum point in between, we are going to decide the maximum power point. So that maximum power point is from the solar system. Okay, so from the solar system, say for example, you are passing the solar light of 1300 watt per meter square. All this 1300 watt per meter square is not converted by per meter square cell. Okay, if I take 1 meter square cell, it is also not converting all the 1000 or 1300 watt per watt energy. It is converting very less. So that less in or shift in that energy is shown here, the gap, what you can see. It is depending upon the efficiency. So this maximum current or the maximum voltage or the maximum power point of the cell, if you speak, it is little bit shifted inside. Okay, so that is defined by fill factor later. So while designing, we have to design for the maximum current and the maximum voltage for the application. This is the maximum power required. But cell, what it will do? The cell will generate only this much of power. So like that, you have to overcome this gap by the efficiency. So you have to improve this efficiency of the cells. Or else in regular time, what they will do? They will take how many possible parallel or series, and whatever the maximum power point is there, it is going to beyond this required power point for the applications. In such case, what they will do? They will take extra cells and they will generate more energy, because here energy wastage is not a point. Also, efficiency we are not going to focus much, because the energy itself is a free energy. So whenever you pay for energy, then people will think about the wastage and the efficiency. But here efficiency and wastage we are not bothered. So in such cases, you can go beyond this power point and you can generate the maximum power, and you can check the applications whether they are running or not. So this maximum power point is nothing but the, what is this? This is the optimum point at which we are going to have maximum voltage and the maximum current from this PV system. So that is denoted by IMP and VMP. Okay, and this is found out. The total area under this curve itself is a power, VMP into IMP. So here you can see the different factors which are written in the equation. Before going to this, again this curve, before defining the fill factor and efficiency, in this curve they have tried to show in the opposite direction, that's all. Reverse bias or forward bias, you can tell. So it is shown in the bottom side. So here this blue color line, what I'm showing, point what I'm showing is maximum power point of the given cell. Okay, from this we are going to get the current and voltage. So current is shown here, J, value of JIS is nothing but short circuit current. This V is nothing but maximum voltage. So here in this graph, what I can say is, whenever there is no sunlight, whenever there is no light falling on the PN junction, then there is no voltage or current. You can see this 0 point. This red color curve indicates without any illumination or without any light or sunlight. Okay, so what is happening here? Because of no illumination, current density is 0, and voltage density, if you see the voltage density, it is also around near to 0. Voltage is also less, here 0, near to 0, this point. Voltage is also less, current is also less. Once it starts illuminating, what will happen? This electron flow will be increased, because of which what will happen? The voltage is going to increase. The voltage is going to increase in this direction, and current is also going to increase in this direction. So just see the values. Don't see the negative sign or positive sign. Just see the values. So in these values, if you see, current is go on increasing as you go on increasing the solar illumination or the radiation. So what is happening here? Due to this, current density and voltage density is improved, and one can now define what is the fill factor and what is the efficiency given for this curve also. Okay, so fill factor is the ratio of products of maximum voltage and current to the open circuit voltage and the short circuit current. The meaning is, whenever the circuit is complete, at that time whatever the voltage and current you are checking, that is VMP and IMP or NPP at this point. When the circuit is closed and maximum power whatever is available that you are taking. When the circuit is open, in such condition, what is the voltage? That will be higher voltage. Okay, so VOC is shown here, this line, green color line, VOC. And at the same point, if you just short the circuit and check the current, what is the maximum possibility of current flow? Okay, without running any application, in that case, I am calling it as ISC or JSC. Means the meaning is the voltage current or the power available from the cell to what is the maximum voltage and current possible, okay, because of the solar light illumination that you can take, or is maximum voltage and current possible for the application or the from the given cell, maximum possible, but what it is actually supplying. Okay, or you can remember like this, you can consider this area, green color line, and to the bottom side, blue color line. Between this, whatever total area is there, this becomes actual area of the cell. Okay, actual area of the cell. Out of that, what is actual power generated now for the use? It is inside this hatched lines for MPP, maximum power point, that is hatched lines. So there is a difference. So this difference defines us what is the fill factor of a solar cell. Means out of total area or the total efficiency, what is required for the application, solar cell is generating less than that energy. So how much it is uh, energy is generated out of the maximum voltage and current what it can generate. So that you can define it as fill factor, or you can define it as the ratio of maximum power voltage and current generated to the open circuit voltage to the short circuit current. If you take the products, that will give you fill factor. Next is this outputs, sorry, this open circuit voltage, if you want to find out separately. So that is for one equation is there. If you want to remember, you can write down this using conductivity of the material given, temperature and heat supply from the sun, and IPH is the phase current, it's nothing but ISC, phase current what is available, and output current I naught plus 1. Using this, one can find out open circuit voltage. And once you know the fill factor of the given cell, now we can go for finding the efficiency. So efficiency relation, all of you know. Everywhere, whenever we call about efficiency, we are talking about output per input ratio. So here, power output is the maximum power which the solar cell can provide. That is Pmax. And input power here, we are talking about the solar incident radiation. Say, for example, the solar constant is 1300. Example, 1300 is the solar constant. But on the Earth surface, we are going to assume around 1000 watt is falling on the surface per meter square. So that 1000, if I consider, out of that 1000 watt solar radiation falling on the solar cell, what is the output power? Okay, and this output power can be found out by multiplying this VMP and IMP. So here it is J. J is nothing but current itself. So maximum current and maximum voltage from the cell, what is achieved. So that you can multiply, which is the output power. And similarly, using this relation, that is a fill factor. Using fill factor, I can replace this IMP and VMP with what? With the fill factor into VOC into ISC. If I multiply fill factor into open circuit voltage and short circuit current, I can tell this is equal to maximum voltage and current. So these two equations will be helpful for finding fill factor and the efficiency of the given solar cells. Any doubts here?
No, sir.
Okay.
Sir,
Yes.
sir, our team is present, sir, to present the seminar.
Okay. Okay. How many are there?
So all 4 members are there.
All 4 members are there. Okay. Just a minute. What is your batch number?
Sir,
You tell the US numbers you tell.
sir 2GI 18ME 113
113. Okay.
136.
136. 18 ME, no?
Yes, sir. Same, sir.
Okay. Next.
136 137
137.
142, sir.
142. Okay. Topic.
So topic is solar heating and cooling.
Okay. Solar heating and cooling. Just a minute. Okay. I think next class we'll discuss our solar PV systems and the problems. Okay, if possible. Or else after your seminar presentation is over, if time is there, I will continue this.
Okay, sir.
Just a minute. I'll stop my presentation. You can present your this one.
Yes, sir.
Let's go. Just a minute. Now you can share the presentation. See.
Yes, sir. Just a second.
Good afternoon, sir.
Yes, continue.
Yes. Uh, Today, me and my friends are here to take up a seminar on solar heating and cooling. So, these are the topic covered. Introduction part. So today, solar heating and cooling is the topic. We already seen that the solar energy is one of the renewable energy. So using that energy, using a solar energy, which is sorry, so using that, we can convert solar energy into useful applications like cooling or heating with the help of photovoltaic cells and reflect solar radiation collectors, etc. So in simple technique, solar radiations are collected in the form of thermal energy, and it is utilized to provide hot water or cooling the pool, etc., or in any commercial applications. So these about applications of solar heating and cooling systems reduce the dependency of electricity. So or indirectly, we can reduce the use of electricity or fossil fuels. So the major function of solar system is to convert the light to heat. The basic requirement. mm the basic requirement of any solar heating and cooling system is to set up a light collector with a high efficiency, that is to absorb solar radiation as much as possible. So why we need solar heating and cooling systems? In our daily life or daily usage, we use a lot of electricity on the fossil fuels. So instead of that, we can use the solar energy, which is already free of cost. Only initial cost setup is to be made. That is planning out where the solar collector should be placed, and initial battery setup, etc. Rather than after that, it will be free of cost apart from annual maintenance services. So in the picture also you can see that solar collector is saving our money in the piggy bank. Even government is also giving some free, not free, but some concession in the electricity bill also. So next, solar heating and methods will be continued by Athar. Hello.
Sir, tell. I'm about to tell that solar heating methods, passive heating and active heating. The passive heating is the direct one, and active heating is indirect. So that solar energy systems use the sun's rays for electricity and other usages. Passive systems are structures whose design, placement, or materials optimize the use of heat or light directly from the sun. And active systems have devices like solar panels or so panels like devices convert the sun's energy into a more usable form, such as hot water and electricity. The active heating is very useful. As Shakti said, it is low cost. Initial cost will be much, but next it will be no cost. So you can see in diagram the passive heat will be directly coming from sun to directly into room through windows or ventilators. In active solar heating, the solar panels will be used so that it will convert solar energy into other energy sources like heat or electricity. And next slide, Shakti. We can see here, you can see the solar heating process diagram, where in every houses they are used normally used. The solar collectors will collect the energy from solar sun, and the it will pass through that panels. The energy will be passed, and the water will be heated here, and the cold water will convert into hot water, and it will be used for bathing and other systems, other use. And the advantages of this, the monthly savings will be, and protecting water quality, protecting air quality. Many additional homes use electricity to heat their water. Thank you, sir. Next slides will be continued by Sumit.
Thank you, Uday, for your explanation. I would like to continue with the solar cooling. As we know, according to the current situation, the global warming is increasing day by day. So the solar heating and cooling system plays an important role, not in the initial time, but for the long run, it is very useful and economical for the human also. Okay, so let us talk about the solar cooling. Solar cooling is a system that converts heat from the sun that into a cooling that can be used as a refrigeration or air condition to maintain the room temperature, or to like regulate the room temperature to a normal daily life. Okay, then and the solar cooling system collects the solar power and uses it in thermally driven cooling process, which is in turn used to decrease and control the room temperatures. As we said, there are like different techniques used nowadays, like absorption cycle or the solar this mechanical cycles. Okay, let's see the common basic terminology which is used here. Okay, regardless of the technique used, a solar cooling system typically includes three core components: a solar collector, which collects the solar radiation from the sun and converts it into a mechanical work or a heat or like vapors, we can say. Then a refrigerant or a air conditioned plant that is used to produce the cooling, which supplies the water throughout the pipelines which is made inside the home. Okay, then a heat sink that collects any rejected heat and radiates it away from the system. That means when we use this refrigerants or cooling plants, as we know that heat exchange is taking place, the heat which is exchanged, which should be like dissipated outside of the home, so to maintain the inner temperature constant. Okay, let's see the components which are used in this SHCS, okay, solar heating and cooling systems. Collectors to take the heat from the sun and passes it to the fluid. This is what we use a solar panel which collects the solar radiation and which converts it into like a heating of the pipes. Or you can say an example of this is in Shridi there is a system used for this, which they can absorb the solar heat from sun, and a water pipe is flowing. A pipe is there which within which the water is flowing. The water is heated up so that it turns out in a steam, and which is used for cooking the food. Okay, then the heat transfer fluid which takes from the heat from the collector to be used as a storage. Okay, we can use this as a heat exchanger. With the help, we can like use the solar energy as heating also for a heating purpose also and cooling purpose also. Okay, then there are some several pumps used in this system which like pumps the hot liquid from collectors to the main pipes which are connected inside the room. Okay, then the collector runs the pump which is collected by the heat absorption. Then the last thing is it is connected to a heat sink which collects the extra excessive heat which is transferred from this internal housing home heat which is generated inside the home. Okay, and the next advantages will be taken by Sunil. Thank you.
The advantages of SHC over the conventional methods are the advantage are the renewable. No, it is a renewable source, sir. No fuel is required, and no polluting, carbon free except for production and transport. Simply low maintenance, sir. It was low cost and simply maintenance. Solar cooling is available when you need it most, and hot water provides some limited storage capacity, sir. The operation of the cost is nearly zero, sir. And next slide, please. Conclusion, sir. Conclusion was solar energy and cooling systems reduce the operational cost as compared to the conventional method. Efficiency of the conventional method and of the heating and cooling can be increased 35 to 40% with the help of a solar heating and cooling system, sir. The main consideration will be to reduce the initial cost of the system in the future, sir. This system provides a healthy environment to the employment and industry by heating and cooling mechanism, sir. Thank you, sir.
Okay. Now cooling part, which all things you have covered here? Once again, open the slide. Solar cooling. Heating is okay. Enough you have covered. Yes. Solar cooling. Okay. You didn't take any refrigeration cycles?
So we went with the basic idea, sir. Like, see, sir, there were like many refrigerant cycles. We went like basic things what are required, sir. If you want to use that in a normal houses also nowadays, we can use that a basic pipeline connection, sir, with a normal heat exchanger. We can use the solar energy, convert it, and use it in a normal things. And we can use the refrigerants are there, sir, present.
No, can I go it
We
for?
focused on the like basics thermal.
Yes. Have you gone
Yes,
through
sir.
that vapor compression or vapor absorption? Which system I can use solar energy?
Yes, sir. Vapor absorption, sir.
Absorption. Okay. Okay.
So
What you
vapor
do now?
absorption chiller is used, sir.
Okay. PPT is okay. You have to make a report. Okay.
Yes.
A small report you have to make.
Yes,
Now
sir.
while submitting, I have just share my screen. Okay. Yes. The screen is visible now. This screen
Yes,
is
sir. The
visible.
screen is visible.
Yes. Here in the class, I have prepared one course activity, that is seminar. Under this, what you have to do, you can inform all the students. Okay. So after presentation,
Yes, sir.
submit the report as well as PPT. Both you have to submit. So rename that PPT and report with your USA number. You can write your USA number underscore report.
Yes, sir.
You can upload one report. Then you can rename the PPT with your USA number and write it as underscore PPT and upload. So under one USA number, I should get
So we
two
should upload.
files, student wise. Each student, both
So
files.
we should upload
Say,
both, sir. Course
yes,
report also and this PPT also.
yeah, both. Say for example, USA
Okay, sir.
number 113 is there here, correct? 113, 136, 4 members are there. All four
Yes, sir.
members will upload same report and same PPT because you have presented in a group.
Okay, sir.
Got the point?
So only
Yes.
the name should be changed, file name.
Yes. No, not name one. That group should be containing same in the report. What's a certificate you write, no? Or on the
Yes, sir.
PPT group members. Group members will be same. Don't change that.
Yes,
Hello?
sir.
Yeah,
Yes.
group members will be same. Don't change that.
Okay, sir.
But as while submitting the file name in soft copy, file name you rename no while submitting.
Okay,
Yes,
sir.
sir.
Yes, sir.
For example,
Got it.
see this document if I open, see the
Yes,
file
sir.
name.
We
Solar
should change the
energy.
file name only.
Yeah. This file name
Okay,
should be
sir.
with USA number. USN underscore. You can write report.
Okay, sir.
Okay,
Yes,
sir.
sir.
For PPT, I will tell you example. 2GI 18ME 142 underscore seminar. Sorry, what is that? PPT.
PPT.
You can write and submit. Submit both the files.
Okay, sir.
Okay, sir.
Presentation
Okay,
of
sir.
seminar you can write. Seminar you can write. And here report should contain all the details like front page, certification, conclusion part. All these things should be in proper format. Okay, and contents it should be same because one batch has presented the same PPT. No, there's no change.
Yes,
So once you prepare the report and
sir.
other things, you submit in this course activity part. Is that clear? So
Okay,
that I
sir.
can
Okay,
enter
sir.
the marks
Yes,
here
sir.
only and I can put it in DHL. Okay.
Okay,
This
sir.
Okay, I think
this is already
since the
created,
time
sir.
is up
Group or
today,
created?
just now I have created in the classwork. Solar energy class.
Okay, sir.
Okay, yes.
Okay, sir. We will upload it.
I
Okay,
think,
sir. Thank you, sir.
Okay, sir.
okay. So time is around 2:35. We'll stop the class here. Uh,
Okay, sir.
Monday class is there 9:45. We'll complete this PV systems and we'll take the last module, that is economics. Okay, hardly I need 3 to 4 classes now to complete the syllabus so that I can keep some classes for the seminar
Okay, sir.
presentations. So just inform everyone to complete
Sir,
this work before
for second
January.
I,
Yes.
sir, for
Yes.
second I, both units are there. Sir, third and fourth.
Yeah, third and fourth I can keep, or third and fifth we can keep.
Okay, sir.
We'll see according to the completion. But first two, if you see, liquid flat
Okay,
bed
sir.
collector is very less. Syllabus is very less. Only numericals are more in both the chapters. Theory, if you see the liquid
Yes,
flat
sir.
bed collector is very less. That's why I kept 1 and 2 units for the first year. Okay.
Yes, sir.
And one more thing,
So for
inform
extra
all the
some
students.
practice, should we refer any textbook?
Textbook I have told no. Sukatme book you can refer or Damkundwar book you can refer.
Sir, actually we don't have any textbooks, sir, because we are at
Yeah.
home
That's why I told
and
before
there are no
lockdown
soft
only
copies
collect the
also
book.
available.
That's why I told in April only
So
collect the book
actually
from the
that there
library.
is limit.
Huh, huh. Then
So we're like all the data handbooks only there are more, sir.
hello. Yes.
Hello, sir.
Huh.
Hello.
Yes. Tell me.
So like we had only like 6 books already.
Okay, I have
And
sent to I
we
have
couldn't
sent
get
to
the
the
last moment.
am I audible to you?
Yes, sir, you are audible.
So there is a
That's
network
why
issue.
in initial classes only I have sent Solar Energy by Sukatma and some other books, soft copy in the group itself, WhatsApp group. And no one is replying in the group, so that's why I left the group. Why it is
Yes,
required?
sir. We can refer that question.
You can refer. It is left to you. That's why. You don't want to refer. You can reply. What is that? You can refer. You have to refer, no? You are telling that can I refer? Can I study? Can I pass?
Yes, sir.
What should I tell for these all questions? Every time it is happening like this only in online. That's why I have left the WhatsApp group. There is no use of that WhatsApp group. So there is no reply or no one is attending the classes regularly. So what is the use of doing all those things? And even after sending all the soft copies in that only, and PPT is also given, like notes only. See this PPT from unit 1, from module 1 only, everything is there. Can you see the screen? Can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
See here, with all solved questions, everything in color, black and white, everything I have tried with all books combinations, everything is there here only. Even no need of books also. See, these all sketches in color because many people will not understand by black and white. They have to understand by some colors. That also I have added here. But what is the use of these things? Hmm? I'm telling to everyone, not only these 4 members, but everyone should refer, no, something what is shared in the group. Okay, whatever. Will not waste time in such things. Or if you want, you can message me. I'll send you the WhatsApp. Okay.
Okay, sir.